Hello, and we are recording. This is Nicole Armand. We are making a video to create the foldable for Chapter 5 integers. It looks like this. And in class, we actually already started making it. We started by looking at this handout here and coming up with what the integers are, the set of integers, the positive and negative integers, the fact that 0 is neither positive or negative, some inverse and opposite information, and then we started using chips to show how we can represent positive and negative numbers. So in the class in which this video is being recorded, we have already done this page and transferred the information to the beginning of the foldable. So if in subsequent classes you're watching this video before we do this worksheet, then we'll just go over kind of a couple of things. If you're in the current class, then you'll get a little bit of repeat. So we did so far the definition of integers, the fancy I, the fancy Z, the positive and negative whole numbers, and 0. We talked about the fact that positive 3 and negative 3 are opposites or additive inverses. They are equal distance from 0, and when you add them, you get 0. We also recorded the definition of absolute value or magnitude, which is the distance from 0 on the number line. And since absolute value is a distance, it's always positive. And we had some examples here. The absolute value of both positive and negative 3 are positive 3 because they're both 3 units from 0 on the number line. However, when there is a negative on the outside of the absolute value bars, you think of that as the opposite. So the opposite of the absolute value of positive 3, which is positive 3, is negative 3. And the same here. First, you take the absolute value of negative 3, which is positive 3, and then you take the opposite of that, which is negative 3. So the reason for this is that for the order of operations, the absolute value bars are a grouping symbol. They count as parentheses. Okay, so we filled in this first page in class. If we didn't in your class, then pause the video and fill this in. And we are going to turn to the first page and talk about addition and subtraction using the colored counters. We talked about the fact that a 0 pair is equal to 0, that they cancel each other out. So we're going to use the yellow side as positive and the red side as negative. Just think of your bank account being in the red, and therefore your bank account is negative. So that's what we're going to do. And in the foldable, you can make it any color. I would make the positive one whatever color you want, green or blue, and then be sure to make the negative one red or some version of red. So these two together make a 0 pair. And no matter how many 0 pairs we have, we always have a net result of 0 because the 0 pairs cancel each other out. So that's 0, that's 0, that's 0, and that's 0. So this whole set of chips has a net value of 0. We're going to use these positive and negative colors to learn how to add and subtract. So we're going to start out with these counters, which again, just like when we started out with the natural numbers, we did concrete models where we were using base 10 blocks and chips. This model is going to be concrete, hands-on with manipulatives. So this first tab here is going to be for addition. And this second column is going to be for subtraction. And we're going to do multiplication and division in part 2. So let's start with addition, and let's write 4 different examples. We're going to use 3 plus 2 as our first example. And then if we use our chips, then we are going to have 1, 2, 3 positive chips plus 2 more positive chips. And that's going to make 5 positive chips. So this is very similar to the set model that we did way back when we made a foldable with a piece of scrapbook paper and fold it in the corners. So I'm going to take a blue or a green color. I used green over here. So if I grab my green pen, then we're just going to say that 3 plus 2 is equal to 1, 2, 3 positive chips plus 2 more positive chips. Oops, I drew one too many. That's what whiteout is for. So we put an equal sign right there in a minute. I should be using my erasable gel pens. And that equals 5 positive chips. So we're going to say that that addition problem equals 5. Now we're going to do 3 plus negative 2. So that's going to be 3 positive chips plus 2 negative chips. And then we're going to notice that based on what we have here in our problem, that we have 2 0 pairs, this one and this one. And that means we can take those out because they cancel. And so the result of our addition problem is going to be positive 1. So let's draw that one out. We have 1, 2, 3 plus 1, 2. And the way I'm going to draw this is with the 3 green on top and the 0 pairs, the ones that we're going to cancel out right underneath them. And then I'm going to cross through the 0 pairs. And then this is how we're going to get that we have positive 1 for this addition problem. We can also add negative 3 plus positive 2. So in that case, we would be putting in negative 3 first and then positive 2. And then we would be saying, are they all the same color? No, they aren't. So that means we get to remove the 0 pairs because they cancel. And that leaves us with negative 1. So we're going to draw that one in where we have 3 negative chips plus 2 positive chips. And then I'm going to draw them on top of each other, and we're going to cancel out the 0 pairs. And that's how we get that this equals negative 1. And then our last example is going to be negative 3 plus negative 2. I like to put the negatives in parentheses like this when I have a positive and a negative next to each other. And in this case, I'm going to have negative 3 counters plus negative 2 more counters Are they all the same color? Yes, they are. And they're all red, so that means that we have -5 as our result. So we're going to draw 1, 2, 3 negatives plus 2 more negatives, which equals 5 negatives. There we go. Okay, subtraction is a little bit different. Something that we should note about subtraction that might make it easier for your students to understand is that subtraction can be done by adding the opposite. So that means that if I want to say A minus B, then I can instead say that this is A plus -B. So let's show how the subtraction model is done without adding the opposite. And then if you do want to add the opposite, we'll write it next to the problem over here, and then you'll be able to refer above. So let's start with the same numbers, 3 minus 2. So this is a takeaway model. We have 3 positive chips, and we're going to take away 2 of them, and that's going to leave us with 1 chip. So this is the takeaway model, the same way we did when we were doing sets. So this is going to be 1, 2, 3, and then we are taking away 2. And the way I used to do that was by drawing an arrow and making an X. You can designate it however you would like. And that's going to give us 1 positive chip left. If we wanted to do this problem by adding the opposite, then we would say that this was 3 plus -2, which we have right here. And we can see that that's also equal to 1. Now let's try 3 minus -2. Somebody is trying to get a hold of me. Let me pause the video and see who that is. Okay, so if we want to do 3 minus -2, we start with 3 positive counters. And now we want to take away -2 counters, but we don't have any negative counters. So what could we do about that? Well, we could add some 0 pairs, right? So we only need to take away 2 of them. Okay, so this is enough, 0 pairs. We could always add more of them if we wanted to, because they would come out later. So if we did our subtraction here, where we decided to remove -2, take away -2 chips, then we would take away these -2 chips, but we would still have the 0 pair here. So you can see here that the result of this subtraction problem gives us +5 counters. So the way we work this is we draw our 3 positive counters, and then we're going to write a note here that we are going to add some 0 pairs. So let me write a note here. We're going to add 0 pairs. And we're going to add enough 0 pairs so that we can take away our 2 negative chips that we wanted to do. So here's 2 0 pairs, and my counters are getting pretty small. So now that I've added this set of 0 pairs, I now can remove 2 negative chips. So if I take that out, then I can see that I am left with 5 positive chips. If I want to write this as an add the opposite, then this would be 3 plus, what is the opposite of -2? That is +2. So this is just 3 plus 2, or the first model that we had up here in addition. Okay, let's try -3 minus 2. So this time we have -3 counters, and I want to take away -2. No, this is not quite how I wanted to explain this one. This is, oh, excuse me. So yes, I just misspoke. I want to remove 2 positive counters. So -3 counters, and I want to take away 2 positive counters, which I cannot do because I don't have any positive counters in my set here. So I'm going to add some 0 pairs. And now I can remove 2 positive counters, 1, 2, and that leaves me with 1, 2, 3, 4, 5 negative counters. Okay, so let's draw that in. We started out with 1, 2, 3 negative counters, and we're trying to remove 2 positive counters. So we can't do that unless we add some 0 pairs. So here's our 0 pairs, and then here are our 2 positive chips that we are going to remove, and that leaves us with 1, 2, 3, 4, 5, -5. And if we want to write this as adding the opposite, then that would be -3 plus, what is the opposite of +2? -2. And -3 plus -2 is this last one right here, and we can see how we got -5 on that one. So for the last subtraction problem, we want to do -3 minus -2. And so for this one, we're going to take 3 negative counters, and the subtraction symbol is our takeaway. And what do we want to take away? We want to take away 2 negative counters. Boom. And we're left with 1 negative counter. So -1, let's draw that. We have 1, 2, 3 negative counters, and we're going to take away 2 of them. And that's going to leave us with 1 negative counter, or just -1. The way we write this, if we want to add the opposite instead of subtracting, is to say that this is -3 plus, what is the opposite of -2? +2. And -3 plus 2 is right here. in our addition line, you can see how we get -1. Okay, so these are the addition and subtraction models for using counters. So the next thing that we're going to do is go to the next tab and take a look at the number line. All right, so let's take some notes here about using the number line as a model for our multiplication, pardon me, for our addition and subtraction. So we're going to start out with looking at the first sign, which gives us the direction. Positive for forward, negative for backward. So we look at the sign and that gives us the direction that we're going to move on the number line. And of course, it's going to be plus will move forward and negative will move backward or in reverse. So remember that we always start at 0 facing forward. Just like before. And then when we talk about the operation of subtraction, that is going to be to turn around. Okay, and again, we can add the opposite on the number line the same way. Okay, so we're going to do the same problems that we did before, where we did the 3 plus 2, 3 plus -2 that we did on the previous tab. So we do 3 plus 2, and we draw our number line. One, 2, 3, 4, 5. Then this is very similar to what we did when we were studying the natural numbers. And we are just going to go forward 3, starting at 0. So 1, 2, 3. And then we are going to move forward 2 more. And that is going to give us 5. To do the next problem, where we have 3 plus -2, we are still starting at 0 facing forward. So we go -3 forward, or +3, excuse me. 1, 2, 3. And then we are moving backward because the sign on the 2 is negative. So I'm going to use red for backward. 1, 2. And we are ending up right here at +1. So on this operation, we went forward 3, and reverse 2. Let's do -3 plus 2. We are still going to start out at 0, facing forward. Okay, so this time we are going to go in reverse 3 units because the sign on the 3 is negative. So I'm going to start out going in reverse 1, 2, 3. That was only 2. 1, 2, 3, all the way to here. There we go. That's -3. Then I am going to go forward 2 spaces. 1, 2. And I end up right here at +1. -1, excuse me. There we go. So -1. And this time we went in reverse 3, then forward 2. Okay, now we want to do -3 plus -2. -3 plus -2. So this time I'm still facing forward at 0, but I'm going in reverse 3 spaces because the sign on the 3 is negative. So starting at 0, 1, 2, 3. And now I'm going to go in reverse 2 more spaces because the sign on 2 is negative. And I end up here at -5. This one was +1, we circled it. This one was -1. And so for this one, we went reverse in both directions, in both times. So reverse 3, reverse 2. Okay, so subtraction is kind of interesting. And I actually have both a little car here that I found in my grandchildren's toy box. This one is apparently like a locksmith car. I have no idea what he did with all his other little toy cars. But I also found this little dinosaur, which I think is kind of cute. And so I want to make like a bigger number line on paper here, which in class we'll actually play around with some number lines that are big enough to use a car and drive around on it. So we're going to have manipulatives in class. So if we did, we're going to do the same operations here. Let's write them down. We have 3 minus 2. We have 3 minus -2. We have -3 minus 2. And then we have -3 minus -2. So I'm going to make my number line on here. I'm going to make it bigger so that my dinosaur has room to roam. So I'm going to kind of make my okay, and so if I want to do 3 minus 2, then I start my dinosaur out facing forward, and I go 3 units forward, and my dinosaur's at 3. But then the operation of subtraction is to turn around. So I turn my dinosaur around, he's at 3, and then I go 2 units. So 1, 2, and I'm moving forward. He's facing forward because I'm doing 3 minus 2. And that's how I end up right here at 1. So once again, I start out at 0, he's facing forward. I go 1, 2, 3, and then subtraction says to turn around. So I turn around, and what am I subtracting? I'm subtracting positive 2. So he goes forward 1, 2, and that's how I end up at positive 1. So let's draw that in the foldable. Here we have our number line, and we have 0, 1, 2, 3, 4. So we are going to go forward 3 units. And you can think of it, the minus 2 as just going backward, because we can think of adding the opposite, right? So, and that's how we end up at 1. So this could be 3 plus negative 2, just like before. Let's look at 3 minus negative 2. So I have lost my dinosaur. Here we go. All right. So 3 minus negative 2. I need some more. Let's see. 4, 5. Right. So my dinosaur starts out facing forward at 0. He goes 3 units, 1, 2, 3. And then he sees a subtraction sign here. We're doing 3 minus negative 2. So he turns around and he's still at 3. And then now we're subtracting what? A negative number. So he goes in reverse 2. So he backs up 2 more. And that's how he ends up at 5. So again, the dinosaur starts out facing forward. The first number is positive 3, 1, 2, 3. Subtraction means turn around. He's at 3. And then now which direction is he going? Backward 2, 1, 2, and he's at 5. So let's draw that one. Okay, so now we are going to draw the next one, where we are going to go forward 3. So 1, 2, 3. And then we are going to turn around and go in reverse. So if we turn around, we're facing the negative direction. So going in reverse means that we're going to go 2 more units this way, and we're going to end up at positive 5. Okay, let's see how we would model negative 3 minus 2. So here's our dinosaur. He's facing forward at 0, and he is going to go negative 3. So that's the backward direction, 1, 2, 3. And then subtraction means for him to turn around. So he's going to turn around, and he's at negative 3. And now he is going forward 2 units. The subtraction was the turnaround. The 2 is to go forward 2 units. So I need to draw in 2 more units for him to hop. 1, 2, and he ends up at negative 5. So again, he starts out facing forward at 0. He goes backward 3, 1, 2, 3. The subtraction says to turn around, and then he goes forward 2 and ends up at -5. Let's draw that in. Again, adding the opposite is fine. If this turning around is making your brain hurt, then we can just add the opposite. Okay, so this time we had, let's see, 0, 2, 3, 4, -5. So we had, he was going backward 3 first, so we like those in red, 1, 2, 3. And then he actually went forward another 2, it's just that he was facing the other direction. So that's how he ended up at -5. So this one is a turnaround and go forward 2. Okay, let's see how to model -3 minus -2. So here's our dinosaur. He starts out facing forward at 0. And the first thing we're going to do is -3. So he moves backward 3. Then he is going to turn around for the subtraction sign. So he's at -3. And then what is he subtracting? -2. So that means he has to move backward 2 spaces. So 1, 2, and he ends up right here at -1. So let's draw that in. So he is going backward 3, 1, 2, 3, -3. And then even though he is moving backward again with the -2, he turned around. So that's why he is still moving backward in the forward direction. So this one is a turnaround. And go backward 2. So we're going backward 2 again, and we end up at -1. So -1, -5, +5, and +1. So that probably made your brain hurt, but that's okay. Let's talk about comparing and ordering integers down here. We're not doing multiplication and division today. That's going to be part 2. So if we want to compare and order integers here, I just want to draw a number line here and draw some tick marks and say that here's 0, and then I have some integers A and B here. And I just want to talk about how we are going to teach students to compare and order integers, because they are now signed whole numbers, positive and negative whole numbers, and 0. So we're going to say that any number that is to the left of another integer on the number line is always smaller. Or less than. So we're going to say A is less than B, and that B is greater than A. Okay, so we have done the counters and the number line for addition and subtraction. We want to turn over here and go to the procedures for addition and subtraction. We did the law of trichotomy in class in the semester that this video was recorded. If we have not done this in class, then please pause the video and write this down. Given any integers a and b, precisely one of the following is true. Either a is less than b, a is greater than b, or a is equal to b. So it's kind of common sense, but we have a law and it's called the law of trichotomy. So now what are some procedures that we need to know for addition and subtraction? Well, we are going to write down how we know what the sign is of an addition problem if we have integers. So this is going to be what students will memorize as they get older when they no longer need the concrete models. So these are the rules. So let's see, right off the paper. So if m and n are integers or positive integers, then if we add the opposite of m and n, then we are going to just get, so same sign, add and keep the sign. We are going to have m plus negative n is equal to m minus n only if the m is bigger than the n. So when we have opposite signs, we always subtract and we keep the sign of the larger number. So m plus negative n is going to be the opposite of n minus m if the n is bigger. So this is just the rules that you know after you're done with all of your concrete models and manipulatives. If you have two integers with the same sign, you add them and keep the sign. If you have two mixed integers, then you always subtract and you keep the sign of the larger number. That's what these next two lines are. This m plus the opposite of m equals 0. That's just the opposite. And then m and negative m are additive inverses. Okay. For subtraction, we are going to write it as the inverse of addition. So for any integers a, b, and c, a minus b equals c, and now I'm going to use an abbreviation. It's going to look like I'm misspelling the word if. But when I write if with two f's like this, it means if and only if. A equals b plus c. So we're saying that subtraction is defined in terms of addition as the opposite operation. We did this exact same thing when we were doing numeration on whole numbers in the foldable way back from chapter 3, I think it might have been, where we were taking the big piece of scrapbook paper and folding in the corners. This is how we define subtraction. Okay, so we have the law of trichotomy, we have number line, counters, For addition and subtraction, we have procedures. On the back, you have the properties that you have glued on there. And then we have this front side. So that does it for us for addition and subtraction. There is going to be a part 2 to this video that is going to give us multiplication and division. And once you watch these videos at home and fill in the foldable, that will give us opportunities to practice in class with the counters and with the number lines and with the little cars that go vroom vroom on the number line. So we'll have some fun with that during class and you'll get to practice. So please make your foldable. I'm going to send out an email to remind you, and then I'll also remind you in class. So I will see you next time for part 2.